Well, hello. Let's have a look at a new kind of annuity now, an annuity due. That's an annuity where the payments happen at the beginning of each period instead of at the end, like they do with an ordinary annuity. In this video, we're going to look at future value due and present value due.
Now, we've already looked at annuities where we've had payments that occur at the end of each period. We call those ordinary annuities. We spent a lot of time with those, but now we want to move on to situations where the payments happen at the beginning of each period. These are called annuities due. Examples might include rental payments, leases, and membership dues. So if you think about paying rent on an apartment, for example, usually you pay your rent at the beginning of each month, and that covers you for the month to come, so you pay in advance. That's different than what we've had up to now with loans, for example, where we pay at the end of every month. And so these are called annuities due, and that's what we're going to work with today. Some of the wording you might have seen already for ordinary annuities are things like payments or deposits at the end of each month or at the end of each quarter and that sort of thing, or maybe something like monthly payments starting 1 month from today, or even loan payments. Those all tend to be ordinary annuities. The wording to look for, the difference now with annuities due, would be things like payments or deposits at the beginning of each month, or the first payment is due on the date of sale, or monthly payments beginning today, or even just the word lease, right? So if you see lease, we know automatically we've got an annuity due. Let's look at some timelines. The top one I've got here is just the ordinary annuity timeline we've worked with in the past. And if we look at that, we've got a term for the annuity that extends from 0 all the way out to n. That's the curly bracket. We've got a bunch of payment periods, and those are the little kind of highlighted rectangles I've made here. And our payments occur at the end of each period. So the very first payment is at the end of the first period here, or at spot 1. Notice that the very last period down here happens also at the end of the term. And that's where we defined our future value to be, and we worked out a formula for that that gave us one number that was equivalent to all those payments. It rolled everything up into 1. So that's fine. We have a formula that really gets a future value at the same point in time as the final payment is made. Let's change our thinking here for a moment. If I think about an annuity due down here at the bottom, the new kind of annuity, we have the same number of periods. That hasn't changed. The term has stayed the same as well. We're going from 0 up to n. The only difference between the two diagrams is that the payment now happens at the beginning of the period rather than at the end. So if I look at the very final period, the payment happened at the beginning, not down with n, not where I want to calculate my future value due. It's one period different. So how am I going to handle that? Well, I do have a formula up top that gives me a future value at the same point in time as the last payment. I could apply that formula down here to get a future value, and then just carry that amount of money forward one period in time, and that would give me a future value due. How do we carry things forward one period in time? Well, for that we just go back to the very first compound interest material we learned, pull out that formula, and in this case that'll be 1 plus I to the power of 1. Well, to the power of 1, we don't even have to write the little 1, do we? So we just have 1 plus I. We can tack that on the end of our original formula that we've been working with so far to convert it to become a formula for an annuity due. And here's what we end up with. The future value, and we'll put the word due beside it so we make sure we've got it straight, is just the old future value formula for an annuity, and then carry that amount forward one period. That makes sense intuitively as well, because if you think about it, payments are going to go now in at the beginning of each period now. So that means they'll get into the bank a little bit sooner, and they'll have a little more chance to earn interest, so they'll become slightly larger Well, that's exactly what's going to happen. We add interest for one period to all of those payments. That's the formula for a future value due. Let's have a look. How much will Stan have in his RRSP by age 60 if he makes semi-annual contributions of $2,000 starting on his 27th birthday? Let's earn 8% on the money. And he doesn't make a contribution when he's 60, so let's have a look at a timeline for that. He starts when he's 27. We want to know how much he has when he's 60. They go in every half year. He does make one when he's 27, but he doesn't make one when he's 60. That's just another way of deliberately saying this is an annuity due, because this final payment, if we think of it as covering us off up to age 60, and we work out the future value due, then that'll be at exactly the right spot where we want to get our value. That's our focal date. So let's go ahead and solve this one. I is 0.04, and N for this annuity, by the way, we've got 33 years, twice a year. It'll be 66. You don't have to overthink N. It's not going to adjust at all. Think about a calendar year as an example. If I pay at the end of every month for a year, I make 12 payments. If I pay at the beginning of every month for a full year, I still make 12 payments. So it doesn't matter when in the period we pay, we're counting the periods themselves, so they don't change. So N we still do the original way. Let's have a look at how this works out. I want to calculate the future value due, and that's 2,000 times 1.04 to the power of 66 minus 1 over 0.04, and then all of that gets carried forward one period. That's the full formula for an annuity due, and that gives me $640,155.60. That's all we have to do. Now you might be thinking to yourself, well, why? Why didn't you just use the original future value formula and pretend, that the annuity started a little bit sooner, went like this, and get the future value? Well, remember, I wanted the value at age 60. That would be at 59. I would have had to move it forward one period. That's exactly what our formula does, doesn't it? And so the formula just kind of formalizes that process of moving the money forward at the end. Here's one for you to try out. Svetlana's going to invest $2,000 at the beginning of every 6 months into her retirement fund. If the investment can earn 7% compounded semi-annually, how much will she have in her account in 25 years? I'm going to suggest that you press pause for a moment and then try this one out. And then when you're ready, press play and come on back and see how you did. All right, let's have a look. For this one, we have a payment going in of $2,000. The interest rate per period is 0.035. We're going for 25 years and paying into it twice per year, so N will be 50. And we want to work out the future value due. Why do we know it's due? Well, we're paying at the beginning of every 6 months. So that's our clue in the wording right there. Future value due for this one, 2,000 times 1.035, power of 50 minus 1 over 0.035 times 1.035. Work that through, and you get $271,165.68. Just that easy. Can we carry on and do a similar thing with present value? Let's have a look. Let's bring this diagram back with the two annuities sort of side by side here. The old present value gave me one number at the 0 point. Now the 0 point was really one period before the first payment, wasn't it? We talked about that earlier. It was at the beginning of the term, or really at the beginning of the first time interval. Well, I now want a value that's right with that first payment. Could I calculate the old present value and carry it forward one? That should give me the present value due, shouldn't it? And that's exactly what we're going to do. It's exactly the same technique we use for future value. So the formula for present value due is the original formula we've used before for present value carried forward 1 period. That's perfect. Once we've got that, we've got the present value due. Let's go ahead and try one out. I'll run through an example for you really quickly. First, the BC Lottery Corporation has all kinds of lotteries, and some of them offer payments over time. And so one of them that they've had in the past is a Millionaire Life Lottery. The top prize is $1 million a year at the beginning of each year for 25 years. What's that worth in today's dollars, really? We know it's not going to be a full 25 million because we get interest on there. We're going to discount those amounts. Let's go ahead and do that. Find out what we'd get in today's value if we did that. I've got a payment of $1 million per year. The rate is 0.035 per year. We get 25 payments, 25 years worth of payments. Can I work out the value today? I'm going to do present value due because it said the payments are at the beginning of each year. Present value due, 1 million. Brought back at the rate they gave us for 25 years. And then make our adjustment for an annuity due. And if we work that out, we get $17,058,367.60. So the real value in today's dollars, if we use that discount rate, this lottery prize is about 17 million. And in fact, if you had one of those tickets and flipped it over, you'd see in the fine print on the back, they would say the winner may choose to either receive $1 million every year for 25 years or a lump sum today of $17 million. So they must have used a rate very similar to this when they went ahead and worked out the value of the prize in today's dollars. I'll give you now one to try out. Let's say we can lease a new piece of machinery for $125 per month for 24 months. Now it's a lease, so it's beginning of month payments. At the end of the lease, so I'm going to throw in a little twist here for you. You can buy the machinery out for an additional $500. So the lease payments weren't quite enough to pay off the machine. If you want to keep the machine, you have to give them an additional $500 at the 24-month mark. You have an option though. Instead, you can buy the machine just straight up for $3,000. You're going to have to borrow money though at 12% to do that. Which option should we choose? And I guess if we're going to figure that out, we should do it properly and figure out the cheaper of the two. And I'm going to work it out in today's dollars. That's what I'm going to suggest you do. If you like, go ahead and hit pause right now and try this one out. This one's a little bit more challenging logically. You're going to need a timeline for this. If you get stuck and you're just not sure where to start, hit play again and I'll give you a clue. And then you can hit pause again and see if you can go from there. All right, so give it a try. All right, so you may be back now having solved it, or you may need just a little bit more of a clue. Let me give you at least the start of a timeline. We've got 24 months to pay for this thing. Just going to put ... in the middle. We can lease it for $125 a month, beginning of month payments. So the one at 23 would take us all the way to the end, wouldn't it? That's the lease. But remember, there's also a residual of $500 due at month 24. So I've got an annuity and a lump sum to deal with on this side. If we buy it, we would have to pay $3,000 now. Now I know I said we'd have to borrow the money. I didn't say we'd have to borrow the money so that we could work out payments, although you could try that. That would be a little bit more complicated though than I think we want to do. The reason I said that was so that you would have a rate to work with. Even though that was the rate for borrowing money, it's the only rate they've given us, isn't it? And so we're going to use that rate for both situations to give us some consistency between them when we compare the options. If that's enough for you to get going, go ahead and hit pause and keep going to finish your work and then come on back. If not, I'm just going to keep going for you now as well, and we'll just kind of work through the rest of it too. All right, so welcome back. Here's what I'm choosing for a focal date. Why did I pick today? Well, usually when we compare options, we want to pick the present value or today's value of them because it makes a little more sense. And then we can look at the difference between the two values in money that we understand what it's actually worth, right? So that's what I'm going to use a future value. Let's work out the present value then of the lease option. Well, that's the $125 a month we would have to pay for 24 months. And it's an annuity due. But don't forget, we also have to pay, so plus 500. Is the 500 in the right place, though? It's not at the focal date, isn't it? So we're going to have to bring that back 24 months as well. That will be the entire present value of the lease. And if we work that out, we can get a present value here of $3,075.76. That's the present value of the lease option with everything calculated and included in. What about the present value of the buy option? Well, we said it was $3,000 today. What's that worth today? Well, just $3,000. We're done with that one. Sometimes it's a little deceiving. You might think, oh, I have to work out payments for the loan at 12% and compare them to the lease. But that's not the case here. It's much simpler just to work in the present. So let's do that. So we've got $3,000 for buying, $3,075 for leasing. So the cheaper option is to buy, and that's $75.76 cheaper. That's the final answer for that one. Now, I know I threw a few tricks in there just to see how you're doing with timelines and that sort of thing. That one may be a bit of a challenge, but keep trying a few more, right? Especially start with some of the easier ones and then work your way up to these. But the idea here is we want to use the present value due formula if we can.
Well, that's it for this video. What I'd like you to do now is have a look at some practice problems on future value due and present value due. And then when you're ready, you can carry on with the next video where we'll look at payment, N, and I.